Hola, bienvenidos a Angaritarad de nuevo. Les quiero presentar hoy a Leonard Nürnberg, quien fue uno de los ganadores del RCNA Cum Laude en Inteligencia Artificial y quien nos visitará en Bogotá este 11 de septiembre en un simposio de IA que llevará a cabo los COS Medical Center. Vamos a hacer una increíble entrevista para hablar los puntos más importantes de la IA en radiología y vamos a empezar con Leonard en este momento. Well, Leonard Nuremberg is our rockstar in AI. He's a researcher and a close friend who received the Cum Laude Award at the RSNA PAS meeting in Chicago. He's joining us today to talk about the future of AI in medical imaging. Because on September 11, for the first time in Colombia, we have the opportunity to have him here in Bogota. He is also a creator of a great page, mhub.ai, a platform that is changing how radiologists access AI models worldwide. Leonard, welcome to our community. Please introduce yourself.
Thank you, Miguel, for the warm welcome. Yeah, so my name is Leonard. I'm now in my fourth year of my PhD. My background is actually not in medicine. I have a classical, well, more or less classical computer science background. Studied computer science and economics in my bachelor in Karlsruhe, Germany. And then I later wanted to specialize myself more with my master, choose AI here in Maastricht in the Netherlands. And from there, I transitioned into the field of medical imaging, where I then pursued my PhD. And as I said, now in my fourth year, one of the main research topics that I worked on was to kind of target the question how we can actually bring AI models into clinical settings, right? How we can make them more reusable, how we can make it easier for people to use AI models that were pre-trained or that emerged from research. And yeah, so I'm very happy to talk about this today with you. Thank you so much.
Leonard, thank you for that introduction. Let me start with the obvious question. You come from a computer science background. How did you end up working in medical imaging?
It was, I mean, one of the things that I love about computer science is, of course, the broad applicability, right? I mean, you can use it for almost everything. So with AI, I mean, I wanted to learn about how AI works. It was 4 years ago, the next big thing. I think these days, NLP, like large language models kind of took over a bit the hype. But when I started, it was pretty much all about imaging, right? That was the big thing 4 years ago, convolutional networks. And I remember I saw a symposium where from Google, they actually presented how a convolutional network works. And I was really amazed by that. I was like, okay, I want to learn this. I want to build this myself. And so I did my master here, which was very hands-on. I really enjoyed the master here in Maastricht. Very hands-on, lots of in-depth experience. And it was actually my master thesis that I did with our master clinic, which is the oncology clinic here in Maastricht. And there I started to look into developing AI models for the segmentation of regions of interest to kind of predict the dose distribution to heart substructures. That was my master thesis. And that was such an interesting project that I felt, okay, I would like to work a bit more in this, right? There is a lot more to discover. And then there was the connection to Professor Dr. Hugo Arts, who is with Mass General Brigham and Harvard Medical School as artificial intelligence and medical imaging lab there. And I joined that team and yeah, that was for me the right decision. So very interesting to get into this pathway.
Thank you. AI has clearly changed a lot of medicine over the last few years. But I want to ask you something more personal. What was the first time you saw an AI model to do something in radiology that really surprised you? Where you thought, wow, this is unexpected?
I think it was so coming, of course, from the technical side. For me, it was more one of my own experiences. It was, I think it was really when, I mean, even outside of the medical domain, I was already amazed by convolutional networks were able to, classify something like, oh, is this a cat or a dog? That was, again, 4 or 5 years ago. That was something. But of course, that gets boring very fast, right? You think, okay, you can figure this out, right? I mean, there's even algorithmic approaches that could go there to some extent. But I think the examples changed drastically over the years. And I think then when I started with my PhD trajectory at the time of master thesis, now about 3.5 years ago, at that time, what was really interesting was to kind of see auto segmentation models, right, that were able to kind of like condense this, this anatomical information and generate like an auto contouring. Was, to me, that was actually really cool if you could see with what kind of accuracy you could reach in these models, especially considering the diversity of and also the amount of details that you have in human anatomy. I think that is very cool. And of course, it was immediately obvious that that is such a big tool. For many applications, you can of course use this for to help in clinical practice, right? To speed up workflows and so on and so forth. But also for research, like we have so big data stacks, right? Like databases full of CT, MRI, X-ray images, and no human has the time to go through all of these images and do a segmentation. And now we have a tool that can do it as good as a human, and we basically just need to press a button and it can run overnight. So I think
One,
that is the real potential, this insane scalability of this approach.
Leonard, there is a conversation that comes up constantly among radiologists, and I hear a lot in Latin America, especially in Colombia. AI is going to replace us. I personally believe that AI will not replace radiologists, but a radiologist who knows AI
Yeah.
will replace the one who doesn't. The problem is most of the AI events are just PowerPoint slides, future presentations, but nothing actually installed, nothing actually runs. What would you say to a radiologist who is afraid? And what are you doing in September 11th to change that?
Yeah, I think the most important thing is don't worry, right? Don't worry about a new technology. I think we should be open, but also careful to some extent. So I think knowledge is always, knowledge is always something we want to acquire, right? There's nothing bad in understanding a new technology. So maybe the more afraid you are, the more you should look at AI, if you so want, right? If you think this is a thing that could replace you, maybe start looking at it right now and start learning what is there to replace you and start finding ways how you can utilize it to make it work for you instead of against you. Long story short, AI maybe, yeah, came over the world in an instance. It might feel too many, but the truth is, AI is something that has been worked on for the last decades, right? Many of these ideas for convolutional networks, as always said, I the first time heard about it a few years ago, and I like 5 years, 6 years ago when I decided for my master trajectory, and I was very surprised to learn that these ideas stem from 20, 30, sometimes 40 years ago, at a time where computers were barely a thing. So I think this shows that this is just something that we as humankind developed. Now is the time where it really broke through, but it is on us how we use this, right? It's a tool. It's neither good nor bad. It's a tool. And I think we can really use this tool to do the right things, but that requires us to know and understand. We need to understand the tool. We need to know how to use it. Especially, we need to know how to use it the right way. We need to understand the challenges of AI, the pitfalls. We need to know where to be careful and where we can rely on it. And I think for that, knowledge and experience is the main goal. So yeah, I would encourage
Okay.
everyone to take this as an
Okay.
opportunity to start learning.
You're right. Let's talk about RSNA. It's the biggest AI imaging meeting in the world. especially in radiology. You received a cum laude award there back in November. How did you came with the idea of mHub.ai, and what problem were you trying to solve?
Yeah, Arsenal was definitely a nice experience. So the idea for the platform started actually already, I would say about 2 years before. It was one of the first of my PhD projects, and it started as a side project. So one of the questions that we were be confronted with ourselves was kind of, hey, I just read the paper, and they used a pretty cool model to segment, well, let's say the lung lobes, and we were thinking, oh, we could also use this for a study that we're working on. Maybe we can quickly run their algorithm on our data. And that sounds quite simple in theory, and in practice, this turned out to be a huge burden. We then later had this when developing our own models that reviewers would ask us, hey, could you please compare your model to this or that model? And it was always a struggle to kind of get these models set up, get them running. And we thought, why is that, right? I mean, AI models seem to be something that was more like a byproduct of a paper and something that was built and trained only to write and report about. But I think, and that's links to what I said earlier, we see AI models as a tool, as something that we want to share and that we want to make accessible to everyone. And that was when mApp.ai was born, the idea to say, let's build a platform that is, and there, by the way, have been many platforms that are concerned training, right? And building AI models, helping people to train AI models. Nice frameworks, amazing work has been done. But we wanted to do something for inference, right? For finding a way how we can bundle AI models so that it is easy for the end user to run them. And the idea is to take away all the burden of setting up the environment, installing multiple packages and dependency issues, and so on and so forth. And we also want to ensure that our models, and we provide a framework that can wrap any model, not only our models, into a format that runs directly on clinical data. Because in practice, as researchers, we would often not use DICOM data, we would use other formats. So we want to bridge between that to say we provide a platform that has models that run directly on clinical data and generate like standardized output that you can directly work with. So all to make it a simple overall experience to run
Okay.
these models.
Leonard, let's talk about the future. I think about the radiologists of the future like a brain divided into parts. One side is clinical imaging, and the other is AI and computation. How do you see the radiologists of the future will be? What will do differently, and how they will stop doing right now in order to succeed?
Yeah, I think that is a very interesting question. And going back to saying that, yeah, AI is a tool, there's really many ways how it can be used and deployed. And I would assume we might now cover one or two of these aspects, but there are likely many more possible. So for one thing is definitely integrating AI into basic workflows and basic routines. We see this in oncology to auto segment regions of interest, to automatically run organ segmentations, also automatic dose distribution calculations, and so on and so forth. Then there's, of course, natural language models that can be used to summarize and structurize data of handwritten reports, right, over entire patient databases and bring unstructured reports into processable data sets. But I think what will also play an important role is like background tasks that we can use AI models to run in the background. For instance, whenever I go to a doctor, I take an X-ray. There can be a whole array of models that run in the background and just assist and alert. We have to be careful here, of course, that we don't over alert, and we should also, of course, I always like to mention this, keep in mind that AI models do not run for free. There's, of course, environmental impacts that we should consider. So we should always run it where reasonable. However, I think that is really one of these big things in the future. It will not, coming also back to that, not replace a human. It will more like assist a human. And I see the radiologist then more as the person that kind of orchestrates this, that is in the responsibility to decide which model to run. That will also be concerned in the position of deciding which model actually is suitable for the job, right? I mean, we have huge diversity of data, we have huge diversity of humans. Few models are actually trained on a really fair cross section of the population. So we have to always be a bit careful and see, okay, which model is actually suitable in which data subset. So I think here we also need trained experts that understand both sides, right? That understand their patients, that
Right.
understand the traditional workflow, but that also know about the potential, but especially here the limitations of AI to deploy it in a safe way.
Leonard, when most doctors think about AI today, they think about, of course, of ChatGPT, Gemini, Claude, the big language models. How do you see generative AI tools will fit into radiology practice? And how does something like the MHub that you built fit in that picture?
Yeah, well, I mean, I think one reason why everybody knows about LLMs is obviously because they have a very nice to use interface. A website, you log on. I think you don't even need to log on to use ChatGPT to a certain extent, right? You can just, I write something, I get a response. Cool. With imaging, it's not that easy. We need a bit more resources. Then also often we have, yeah, we deal with sensitive information here. If I provide you a website, you should be careful whether you want to drop actually that CT scan on there or not. Most likely you do not want to do that. So what we instead did with MHub, the idea was to kind of, we define the framework and we pre-bundle our models. So we have now about 30 models, and this is growing as it's an open platform, so everybody can contribute here. But we provide the models, but we do not provide any infrastructure to execute these models. So that means everybody can run these models on the local machine or on their local server or infrastructure. Some of these models need some hardware requirements. Since we deal with images, sometimes very large images, processing them in a reasonable amount of time needs a GPU. But many models can also run on a CPU. That means on every laptop. You just need to bring in some time. So I think that is a very good way to start learning about AI models, right? Simple to set up. You just download the container, you run the container, point the container to your input images, and you get the output in an output folder, and then you can go from there. So we try to make this as painless as possible. And what we want to do on the symposium in the workshop is actually to kind of showcase this, right? To make it a guided experience where everybody who attends has the opportunity to go with us together through the steps from start to finish to deploy one of our AI models on their local machines. And how this platform is built is that this knowledge transfers to all the other models that are out there. So after that, you will be able to go online, browse for one of the other models we have in the catalog, and run that model as well. And if you say, well, now I have this on my laptop, this is nice, but I actually need to process a larger data set, maybe to prepare a study. In that case, you would then you could rent a machine, you could rent a server, you can run the same model there, use a powerful GPU, and process a larger data set. I think that's the beauty, that this is completely platform agnostic and flexible. You can run these models very easily on different architectures.
Leonard, thank you so much. We will see you in person in September 11 at the Los Cobos Medical Center Symposium in AI here in Bogota. We are looking forward to it. Thank you for your time in this wonderful interview.
I'm excited. Thank you so much, Miguel. Bye.